In today's math lesson, while discussing the slope-intercept form, we are going to write an equation from a table. In beginning this process, the first thing that we have to find is the slope. In a previous lesson, we discussed that as you are given a table, we can find the slope, m, by analyzing the change in y values divided by the change in x values. We found these changes by determining how we went from row to row. The triangle symbol means to change. So on the right side of the table, how did the y values change from one row to the next? On the left side of the table, how did the x values change from one row to the next? This ratio is our pattern. It's the slope. After we have found the slope, the pattern of movement from row to row in the table, we have to then find the y-intercept. To do this, we have to answer the question of what is the y when x is equal to 0 on our table. So yes, this does mean whenever x is equal to 0, the y value corresponding to that is the y-intercept. You could say, you definitely can say, that the coordinate point of 0 something, this is our y-intercept. Sometimes your table is going to show you this directly, and sometimes it's not. So what happens if it isn't showing on the table? Well, after you figure out what the pattern is from row to row, after you determine the slope, you're going to use that pattern to walk or roll the table backwards until you get to x equaling 0. This will tell you what your y-intercept is. Once you have both of these pieces of information, both the slope and the y-intercept, then you can go ahead and write the equation from your table. Example 1. Looking at the given table, we are going to write the linear equation that gives the rule for the table. Step 1 is to go ahead and find the slope, which we remember from a table can be found looking at the change in y values divided by the change in x values. So here on our table, let's do exactly that. And truthfully, it doesn't matter which two rows you pick to use to analyze, because we have already been told this is a linear function. So I'm going to actually choose the bottom two rows, because why not? So here on the right side of the table, we have our y values. So the change in y values, to get from 7 to 8, you add 1. Yes, you do. And on the left side of the table, looking at the exact same two rows, we're going to look at the change in x values. To get from 2 to 3, you again have to add 1. As a result, I can now say that our slope, our change in y divided by the change in x, will be 1 divided by 1, and I got those from right here, which is equal to 1. So our slope, our m, is 1. Now that we have determined the slope from our table, we have to go find b. And b happens when x is equal to 0, so thus we have to just determine what y is equal to. What is the corresponding y when x happens to be equal to 0? On this table, on this example, we have been told where x happens to equal 0. And as a result, we know its corresponding y value. This 5 right here, this is b. So without any work or stress, we know that b is equal to 5. Now we are ready to go ahead and write the equation that corresponds to this table. Remembering that we look at y equals mx plus b. Let's fill in our slope and our y-intercept. So y equals m, which is 1, x, plus our y-intercept of a positive 5. Also remembering that usually a 1 for a coefficient of x is not stated. You're not going to see that on a digital platform or on a worksheet. So you would simply say, oh, the 1 is understood to be there. You don't need to show that 1. Therefore, y equals x plus 5. And there you go. Example 2. Looking at the given table, we need to write the linear equation that gives the rule for this table. Step 1. Let's go find the slope, the change in y values divided by the change in x values. So looking at our table, where the y values are always on the right side of the table, you can pick any 2 rows to analyze. And I like to work with the bottom 2 rows, but truthfully, it's totally up to you. To get from -8 to -12, we are going further down. I like to tell people the negative numbers are down in the dirt. And so if you are -8 feet, if you are down 8 feet in the dirt, and you are going further down in the dirt to 12 feet, you have gone down an additional 4 feet. That's how I like to explain that. Positive numbers are up above the dirt, up in the air. 0 is the line of the dirt, and the negative numbers are down in the dirt. That's how I think of those. All right, back to finding the change. So the change in x values, to get from +2 to +3, all you had to do was add 1. Therefore, our slope, the change in y values was -4, the change in x values was +1, and -4 divided by +1 is equal to -4. This is our slope. Now that we have found the slope, we have to go and find b. And we remember that the y-intercept happens when x is equal to 0. So the question is, what is the corresponding y value to x equaling 0? In this particular example, our table shows us when x is equal to 0, which is great. So as a result, the corresponding y value of x equaling 0 also happens to be another 0. So our y-intercept is 0. Now we have all the information that we need to write our equation as y equals mx plus b, the slope-intercept form of an equation. So let's do that. Y equals, our slope, m, is -4. X, because it's the variable that you use, plus b, where b happens to equal 0. As we discussed in a previous lesson, while this is technically accurate, many teachers and many digital platforms are not going to want to see a 0 added at the end. So all they're going to want is y equals -4x. While truthfully, these are both worth the same thing, they mean the same thing, platforms and teachers have preferences sometimes. And there you go. Example 3. Looking at the given table, we need to write the linear equation that gives the rule for this table. To begin this process, we need to find m from our table with the change in y values divided by the change in x values. So let's do that now. So on the right side of your table, we have the y values. We are moving from a value of 41 to 54. So clearly we are adding, and the question is how much? 41 to 54, we are adding 13 units. On the left side of your table, where the x's are, to get from a value of 3 to 4, we just have to add 1. So our slope, the change in y divided by the change in x, will be 13 divided by 1, which is just 13, and that is our slope. That is our M. Now that we have the slope, we have to find B, the y-intercept. And we know that happens when x is equal to 0, and we just have to determine its corresponding y value. Okay, this table does not show us where x is equal to 0. We have to go find it. So we're going to walk our table backwards, so to speak. So we do that by extending our table upward. So if you're doing this on paper or on a whiteboard, you might want to write out this table giving you some room above it so that you can say, okay, I need x equaling 0. Let's look at our x values. 4, 3, 2, 1. I just need to go one step backwards to 0. So now we use the pattern of the y's to walk us backwards to this one location, as this will be our B. Whatever that is, we got to go find it. So 54 minus 13 will give us 41. 41 minus 13 gives us 28. 28 minus 13 gives us 15. So we continue that pattern of walking backwards. 15 minus 13 gives us 2. As a result, our y-intercept of B is equal to 2. Now that we have that, we can go ahead and write the slope-intercept form of our equation, y equals mx plus b. So let's do that with y equals our slope m of 13, x, the variable in our equation, plus b, our y-intercept. And our y-intercept is positive, thus we have a plus in the middle. And there you go. Example 4. Look at the given table and write the linear equation that gives the rule for this table. Step 1, we need to go find our slope, the change in y values divided by the change in x values. So let's do that. Nice and simple, same process that we've been using to get from -6 to -7. So you are 6 feet down in the dirt, you are going to a 7th foot down in the dirt. You are subtracting 1. You are going further down in the dirt. To go from +6 to +7, you are moving up 1 foot. Okay, up above the dirt, so to speak. So our change in y values is -1. The change in x values is +1. A -1 divided by a +1 is -1. Thus, our slope, this pattern, our rate of change for this particular table is -1. Now we need to go find our y-intercept B. And we know this happens when x is equal to 0, so we have to find the corresponding y value for it. All right, so we do not have x equaling 0 shown to us on this table. We have to go get it. So we do that by extending our table upwards, just so we have more room. Let's go see what values we do have. On the x side of your table, we have 7, 6, 5, 4. Let's go find the rest. 3, 2, 1, 0. Okay, that's as far as you needed to go, as we know that whatever the y value is when x is equal to 0, this will be our B. Now we're going to walk our table backwards on the y side using the pattern that we have seen shown. -7, -6, -5, -4. If you add 1 to it, because we're walking backwards, that's -3. Add 1, that's -2. Add 1, that's -1. Add 1 more. That is also 0. Thus, B is equal to 0. Our y-intercept is 0. Now we have all the information we need to write our equation in slope-intercept form. y equals mx plus b. So let's go ahead and do that. So y equals our slope of -1, x, plus b, our y-intercept of 0. We have stated in previous examples in this lesson that your digital platform or your teacher might have real opinions on exactly what you show when there are ones and zeros in your equations. So you may need to refine this a little bit with, while you don't have to show the 1 for the slope, you definitely need to show the negative. So this will be y equals -x, as the 1 is understood. And we don't show +0 for many teachers or digital platforms. So we would just stop right here with y equaling -x. Yes, both of these equations mean the exact same thing, but truthfully, people do have opinions, and digital platforms are designed by people who have opinions. So yes, both of these are correct. So there you go. Our fifth and final example has us look at the given table and then write the linear equation that gives the rule for the table. We start this process by looking for the slope, and we do that by finding the change in y values divided by the change in x values. So 74 proceeds forward to 93. How did we do that? We added 19. That's quite a bit. And 7 proceeds forward into 8. How do we do that? We added 1. Thus, our slope will be 19 divided by 1, which is just 19. So there's m. There's our slope. Now that we found the slope, let's go find the y-intercept. And we know that that happens when x is equal to 0. We just need to find the corresponding y value. We do not have on this table an x value of 0 showing, so we need to go find it. We do that by extending your table upward and then walking your x values back to 0. So let's see how it works. 8, 7, 6, 5, 4, 3, 2, 1, 0. All right, we've walked it back to 0 on the x side. That's exactly where we need to go, as its corresponding y value will be the b, the y-intercept. Let's do that. So our pattern had us using 19 on the y side of the table. So we're going to use that 19 to walk us all the way backwards. Let's see how it goes. 93 minus 19 is 74. 74 minus 19 is 55. 55 minus 19 is 36. 36 minus 19 is 17. 17 minus 19 is -2. -2 minus 19 is -21. -21 minus 19 is -40. And finally, -40 minus 19 is -59. So our b, our y-intercept, is -59. We finally found it. Now that we finally found our y-intercept, let's go write our equation in the slope-intercept format of y equals mx plus b. So y equals m, our slope of 19, x, that's the variable in our equation, and then we have our y-intercept b of -59. We don't write plus minus. We only have one symbol, and being that our b, our y-intercept, is negative, we just show that with a minus. And we now have our final equation. And there you go.